Right now, there's a material sitting in your kitchen drawer that has literally been to the moon. It's inside your phone, your car, and it's even buried in the wiring behind your very walls. Doctors even trust it inside the human body. Yet despite being almost everywhere, most people can't even name it. No, it's not plastic. It's silicone with an E, not silicon, and yes, those are two completely different things. This all starts with sand. Sand is mostly silica. Strip away the oxygen and you get silicon, the element, the stuff computer chips are named after. Silicone comes later. Take silicon, rebuild it into long chains with oxygen, carbon, and hydrogen, and suddenly you've made something that behaves unlike almost any other everyday material. Same starting point, completely different personality. This whole story actually kicks off in 1943, over in Midland, Michigan, when Dow and Corning Glass formed Dow Corning to work on silicone products for military use. Aircraft needed components that could survive heat, cold, vibration, moisture, pretty much anything nature could throw at them. One of the first products was an ignition sealing compound that helped high-altitude flight work better. Not a bad first job for a material that would eventually end up as your favorite kitchen spatula. The war ended, silicone didn't. Silicone isn't exceptional because it's good at one thing. It's exceptional because it's good at several things that normally don't go together. And that's all because of how it's built. Instead of carbon atoms like most plastics, silicone is built around alternating silicon and oxygen atoms. That gives it a temperature range many everyday materials simply can't match, roughly -60 to around 450 degrees, depending on the formulation. It stays flexible, resists chemicals, and is gentle enough for skin contact, while still being tough enough for demanding engineering jobs. This heavy-duty military material slowly migrated right into ordinary American homes because it actually solved problems. It doesn't melt in the oven. It doesn't crack after a few years. Food doesn't stick to it nearly as much. Sometimes the boring engineering solution wins. Then came aerospace. NASA used silicone rubber in Apollo spacesuits, including the fingertips of the gloves, and later relied on silicone seals in spacecraft systems. Space is brutal. You're dealing with a total vacuum, extreme temperature swings, intense radiation, and absolutely no repair shop around the corner. If a material earns NASA's trust, engineers everywhere tend to notice, and silicone earned it. Then silicone crossed the line very few materials ever do. It went inside the human body, where the standards get even stricter. The FDA regulates silicone medical devices, catheters, prosthetics, implants, because in carefully controlled forms, silicone is remarkably stable and doesn't react much with the body. That's an unusual trait. Most materials want to interact with their surroundings. Silicone mostly minds its own business. In medicine, that's exactly what you want. Even when you can't see it, you're still probably depending on it. It insulates wires, connectors, and electrical components in your home, your car, and the devices you use every day. Nobody notices insulation until it stops insulating. And that's just one job. Silicone is in everything from spoons and kitchen utensils to window seals, aquarium sealant, gaskets, hair conditioner, and even bathtub caulk. Once you know what to look for, you start noticing it everywhere. Now, it's not perfect. Silicone is durable, that's the whole point, and also the catch. The same stability that makes it useful makes it persistent. It isn't biodegradable. Recycling is possible, but it still isn't common. Material science rarely gives you a free lunch. Every advantage comes attached to a trade-off. One last thing. When people say silicone, they're talking about a whole family of materials. Silicone oil flows, so you'll find it in lubricants and hair products. Silicone gel cushions things, which is why it's used in medical bandages and prosthetic liners. And silicone rubber holds its shape while staying flexible, so it's in your spatula, your phone case. Same backbone, three very different outcomes. A material born in wartime America, proven in space, medicine, and millions of everyday products. Not bad for something most of us only know as a kitchen spatula. That's silicone. Blueprint revealed.